How do you choose device classes for your embedded design? You have to study the specs, but you also have to apply practical knowledge. Hi, I'm Terry Moore of MCCI. Let's talk about USB. Device classes are the glue that hold USB systems together. They take basic commands from Chapter 9 of the USB core specification and add meaning, semantics, appropriate to the kind of device you're controlling. Meaning what? Here are some examples. For a mouse, a USB mouse, the device class specification says that moving the mouse results in a specific kind of message indicating how much the mouse was moved. Clicking a button sends a different message, one message for button down, one for button up. So it's pretty simple. Another example, for USB thumb drives, the class specification tells the host how to read and write blocks on the drive. Again, conceptually, it's quite a simple idea. In theory, if you build a device that complies with a known device class, you'll be able to operate with any host. And if you built a host with the needed class drivers, you can operate any device. But you knew that was coming when I said in theory, right? Just as there are a lot of different kinds of devices, there are a lot of different device classes. We can sort them into different categories. Classic device classes represent traditional devices that have migrated to USB. Audio, mass storage, keyboard, mouse, webcam, printer, smart cards. Most operating systems have built-in support for these classes. Communications devices allow the computer to talk to other devices or other computers. Serial ports, modems, network adapters, Bluetooth. In some sense, if they do their job, they're transparent to the user. These are pretty common too. But we start seeing more variety of ways to do the same thing. Look at all the different networking classes: ECM, NCM, EEM, remote NDIS, MBIM. A lot of different ways. Moving along, power delivery classes are infrastructure for the USB power delivery technology that's part of the Type-C connector. Users should never encounter these classes, but system vendors may well need to consider them. Niche classes are used in specific industries. The most commonly used one is DFU, Device Firmware Update. It's very unusual for host systems to have standard built-in support for these. These devices are almost always shipped with dedicated applications. Standardization is more of a convenience for the manufacturer and supply chain, rather than a matter of enabling generic communication. Finally, there are a lot of special, historical, and meta classes. These are relevant to specialists, but they're not important for new device development. Beyond the industry standard device classes, there are proprietary classes that are quite important in practice. Each class is implemented differently based on the manufacturer's decisions. There are 4 main classes of devices in the market. USB serial converter chips are largely proprietary. The most popular are prolific FTDI and Silicon Labs. You'll see Arduino and other kinds of embedded computers that use the CDC ACM class. But if it's a chip, it's probably proprietary. USB to Ethernet adapters are generally also proprietary. The most popular are ASICs and Realtek. These chips come in several versions, and you generally need different drivers for different generations of chips. USB to Wi-Fi adapters are always proprietary because for some reason there's no USB standard class for Wi-Fi adapters. MediaTek is most common in embedded systems, but Atheros and Realtek are also strong players in this market. USB display adapters are generally proprietary because the AV class spec was not successful in the market. DisplayLink is the key vendor in this area. There are a lot of device classes. This is good. The wealth of device classes is what has made USB universal and ubiquitous. But it's a challenge for system designers. It's an embarrassment of riches. Here's what I mean. There are a lot of standards. I counted over 50 documents labeled device class specification on the USB website. Some specs, like the Bluetooth and USB 3 Vision specs, are not even on the USB website. You have to get them somewhere else. And they have their own IP agreements that you have to go through. The specs can be large and complex, even for simple devices. Remember the simple mouse example? The essential portion of the device specification can be expressed on a single page of text. It's on page 61 of the spec, to be precise. But this simple function is wrapped in a much more complicated framework called HID class or HID class, short for Human Interface Device. The HID class spec is 2 documents, about 270 pages in all, which covers not just mice, but keyboards, joysticks, audio controls, digitizers, even alphanumeric displays. So it's a pretty big thing to comprehend. The complexity is understandable when you consider that the standards were developed in industry committees. Important contributors needed special features to support devices they were already making. Generally, the committees are composed of experts who understand their topic very well, and they write for their peers, rather than for the people who aren't in the room. This makes it difficult for developers who come along later. The final point I'll make is that the specifications often include visionary features that were never implemented. They were rejected by the operating system vendors, they were too far beyond the state of the art, or they did not work out the way that was expected. I'll give you an example from the committee I currently chair. The communication class specification for modems uses something called encapsulated commands. These were a great idea, but they were never actually put to use. I'll close by running through a quick, incomplete list of questions about device classes that you need to ask when planning your product. Will the candidate device class do what I want? For example, if you're building a USB to HDMI adapter, you can't use the USB video class. That's for webcams. You either have to do something proprietary or develop a complete USB AV class stack, which is daunting. The next question to ask is, do Windows, Mac OS, Linux, and so forth support my device class? If not, you may have a problem. Even if they do, are the OS requirements of the device consistent? For example, Windows for many years required audio 1.0, but Mac OS preferred audio 2.0. It's hard to build a device that is both. Even if there's host support for the device class, do all the hosts support the features you need? Some hosts may only support bulk transfer, and others may only support isochronous transfer. This is a common problem with video class. Finally, are there certification or compliance requirements that come from USB-IF or from the organization that created the standard or from the market? This may drive your choice because it may affect the economics. This kind of complexity is why people turn to MCCI. We've been members of USB-IF for over 20 years, actively contributing to the development of USB technology. We have an unmatched depth of experience and know-how. We have pretty good software, too. We understand that a big part of what we do is helping customers make the key decisions and serving as a long-term repository of design knowledge and know-how. That's all we have time for now. Check our website, mcci.com, for more information on our products and services. Bye now.